Today we're going to see a very important concept called the coefficient of restitution. And in coefficient of restitution, it gives us an indication of how elastic or plastic the collision is. And we have a vehicle in here that is being driven into a barrier test. And let's observe first what happens when it collides. So we'll turn it on, and then you can see we're using SimWise 4D, a software that is used for simulation. And in here you can see on the left hand on the screen, it is we measure the impact impulse in here as the car collides. Now you realize that the car bounces back, but it doesn't bounce back with the same velocity that it came in, and also does not bounce back to the same place. So we have a couple of possibilities, maybe three possibilities. One, that the car will bounce completely. Two, that the car gets stuck and doesn't bounce at all. And three, that it bounces a little, not so much. Vehicles don't have elastic collisions completely. They also are not plastic collisions completely. They are someplace in between. This number that we're going to be talking about here measures how elastic or plastic this collision is. In order to illustrate this, let's go and do a simple experiment. We're going to stop the simulation here, and let's switch to a simple experiment that we're going to use. Here we have a ground, just a slab in here, and just a ball in here. And I haven't given any values or anything in here, but just the default ones that the program working model 3D allows. But if I double click on each one of these bodies, you can see it has the properties, the position, the masses, and everything. But it has a little number in here called the elastic. How elastic is this? This is the so-called coefficient of restitution number. And this is 0.5 by default. This one also 0.5 by default. If both of these bodies are 0.5, the collision may take place, but I don't expect it to be totally plastic or totally elastic. So I am going to measure the position of this in the y direction is what I'm interested on, and I'll do a plot as I release the ball. So go in there and you can see it bounces a couple of times and stops. But what will happen if we change those numbers? I mentioned to you when we were looking at the car that there was three possibilities. One, that it will bounce completely. Two, that it won't bounce at all. And three, that'll bounce a little, but not completely like original. So what I'm going to do is I'm going to play with those numbers and see what the results do I get. So the very first thing I'm going to do is I want to make sure that both of these bodies are in the same, have the same coefficient of restitution. So I'm going to put this a 1, so that both of them, and this also I'm going to use 1. Okay. And what should we expect it will happen? What we expect it will happen is, I'm going to move it over here so we can see it. So if I run this, look what happens. It will bounce forever with the same height, no loss of energy at all. And it would do reset, you see, it bounces and it will continue forever and ever the same way. fact, we could just let it run so that you see this is steady state condition. Yeah. But if I stop it and then I reset this, I'm going to erase the history of this so I can see it again. But this time I am going to put it at 0 here. This indicates a totally plastic collision. And this also at 0. I have to do both of them because if one is different, then the computer is going to take the less and less value. See what happens in this case? It doesn't bounce at all. Goes runs, click, which is we expect to demonstrate this number called the coefficient of restitution as being a number that indicates how plastic or elastic the collision is. In this particular case, it goes down, stays there, that is totally plastic collision. But if we were to reset the coefficient of restitution like it was at 0.5, or let's say I would do like in the case of vehicles, more or less around 0.1 here. 0.1 would give us already some bouncing, but not too much. Yeah. And let's just try to see how it is, because you're going to see that vehicles behave like this. So what I'm going to do is I want to switch the scale of this. So I'm going to define it again to measure the position in the y direction. And I have it over here. This is just so that I can see it better, nothing else. So in here we go and we say, okay, very good. We run. See? It bounced, but very little, if any. In fact, in this case, it's so close to elastic collision that we are not noticing it in here. We might have to go this to 0.3 maybe. And then we'll see what happens with 0.3. So this is 0.3 over here instead of being 0.1. Let's see what happens now. Let's run it. And you can see it bounces a little here, but no more than just a little bit in here. This is the way vehicles behave. Vehicles don't bounce like billiard balls, totally elastic. They don't. Depending on the amount of deformation, they are really close to plastic collisions. And if not, just a little bouncing. But this demonstrates the number that I wanted you to evaluate and have an idea. And now the picture that you see here would make more sense for you. Because in the collision you see there is some bouncing, but not completely bounce to the original position. And the coefficient of restitution, we expect that this would be between maybe 0.1 and 0.3 or so. But that is the concept there. But the important thing is to be able to understand what that concept is. So, and we have demonstrated what that number does and what the coefficient of restitution is.